Alright class, so we're going to make a quick video here just going over the information we did today in class on how we're able to use numbers to plot data and create graphs out of it. That way you can kind of go back and reference this video as you are working on your lab and doing that part 2 where you're going to need to create a graph based on some data here. So what we have is that same data table of our displacement of our spring compared to the force that the spring exerts. What I did was I went ahead and copied down this data table onto a separate piece of paper, just that way I could go back and forth between the two pretty quickly as I create our data table numbers. So what I'm going to do now is I'm going to exit out of PowerPoint. I'm going to go and open up Numbers. And what I'm going to do is just to create a new document, go to the plus sign in the top right hand corner here and start a new document. So what we have is it pulls up a kind of blank page here. As we can see, this A column is going to be highlighted in gray. Our row number 1 is going to be highlighted in gray as well. So what I'm going to do to start my data table to plug in is just start with the box that's been highlighted for us. So I'm going to take the displacement of our spring, that first column in our data table. I'm going to just plug that into our column B here. So just recreating the data table into numbers. So by clicking on it, I can now switch over to numbers here. So our first value we had for our displacement was 0.10 meters. Then next column over, we're going to have our force of 6.0 newtons. The next data entry we had was a displacement of 0.15. This had a corresponding force of 10.0 newtons. So again, all I'm doing here is just recopying our data table that we had up on the PowerPoint slide. So next we have a displacement of 0.25, a force of 17.0, had a displacement of 0.30, a force of 21.0 newtons, displacement of 0.35 meters, force of 23.5 newtons. A few more data points to go here, so 0.40 and 26.0 newtons, 0.45 meters, and 30.5 newtons. Last data entry is going to be 0.50 meters displacement with a force of 35.0 newtons. So what we have is we've just recopied our data table into our first two columns here of numbers. Now in order for us to create a plot or a graph of this data, I'm going to select this 0.10, our very first box here, and I'm going to click on the bottom right edge where there's that circle. It's going to allow me to drag it down and over, so we have both of our columns of our data table highlighted. Next up, I'm going to go to the top right-hand corner of our kind of toolbar here. I'm going to click on the plus, and this gives us an option to either create a table, create a graph, so on and so forth. So what I'm going to do is select this second tab over here that looks kind of like a pie chart, and I'm going to scroll down and pick the one that has a bunch of pluses in off to the right side here. So what this does is creates a scatter plot for our data. Now in looking at this graph here, there's a couple things that we're going to want to see in ours. First thing we're going to do is give a label to both our x-axis and our y-axis, and that way we know kind of what variables we plotted on each of those. I'm also going to want to give my graph a title, and last thing we're going to do is create a trend line here, so that way we can use the equation of that trend line to figure out what our spring constant is for this spring. So what I'm going to do first here is just click on our table, and what I can do is click on this Edit References tab that pops up. All it does is allows me to go back up and check, make sure that we have our first column is plotted along our x-axis, which is good, that's what we want. And our second column is plotted on the y-axis, also good, that's what we want. Again, we want displacement along the x-axis and force along the y-axis. So I'm just going to click off, go back to our table. So I'm going to then select it again. If I go up to that toolbar in the top right, I'm going to click on the one that looks like a paintbrush. Now the first thing I want to do is give a name or a label to our X and our Y axis. So to do this, I'm going to click on the second tab at the top which says Style. And then under the value for X axis, I'm going to click on selecting axis name. So you can see what happens on our graph there. There's a name that pops up that says value axis. I'm going to do the same thing under the value Y axis. I'm going to click on axis name. Again, we see a label pops up on our graph. I can then click off and I can go in to edit these. So if I click on value X axis, take a little bit of time just to click it exactly here. There we go. So along our X axis, we're going to want to call this one the displacement of our spring. So we'll type in displacement of spring. Again, that was going to be measured in meters, so just in parentheses, I'll put an M here. Let's know the unit for those measurements. I can then go to value of y-axis. I can change that. That's going to be our force is plotted along our y-axis. Again, our force is going to be in terms of newtons. You can put that unit in as well. All right. Next thing I want to do is give this graph a title. So again, click on the graph, go back up to our paintbrush here. I'm going to switch back to that first tab that says Chart. And from there, what we have is title, caption, legend. So the legend, all it is that dot at the very top of our graph. It tells us kind of which data table has been used to plot the lines. So we only have one set of data. We don't really need it, so I'm going to just click off of that, and we'll see that blue dot at the top disappears. Now I am going to want to click on title to select that one. So what I can do is rename our title. In any sort of graph we make, we always title it our y-axis versus our x-axis. So in this case, what we're doing is we're plotting the force of our spring versus the displacement of our spring. So this graph will be titled force versus displacement of spring. Last thing we're going to want to do to help us figure out what the spring constant is from this data set. And again, click on the data, go back to our paintbrush. What we're going to do is scroll down to the bottom here, and where it says trend lines, I'm going to click on that, and the type of trend line I want to add here is going to be a linear one. We want to have a line go through our data. If I then go back to the trend lines menu there, what I can do is in the middle here, show the equation for that line and show an r-squared value. So what this does is it gives us an equation in the format y is equal to mx plus b. Now, what we have in this graph is what we have in there for m, the slope of our line, that's going to be what our spring constant is. So in this equation, y is equal to 69.33x minus 0.4667. We can gather that the slope is going to be 69.333. That tells us that's going to be the spring constant of this particular spring. The r-squared value, that's actually something that we're not going to really worry too much about, but all it tells us is that the closer that number is to 1, the better our trend line is in terms of describing our data. So as we can see here, our r-squared value is 0.9953. That just means we have a very good trend line. When we look at kind of our data plot here, pretty much all of our data points or our dots either go through or are touching our trend line. So that just means we have pretty consistent data here. So guys, again, as you're working through your lab, feel free to go back, reference this video as you are plotting your own trend lines here and creating graphs.